Now, before I go further, I want to describe one of the problems that we know arises from programming historically. And that is, I will have a chunk of memory allocated to the running of my program. And some of it will contain instructions. The ones and zeros are interpreted as instructions, and all else being equal, it goes from one instruction to another. And those instructions will reference memory addresses where there's data, and it will manipulate that data according to its type. Now, the instructions don't always execute linearly in order, because some of the instructions will say, well, if such and such is true, jump to some other instruction that's out of sequence, and then it will proceed in sequence from that point until it reaches another instruction that tells it to branch someplace else. So part of the memory is instructions and part of it is data. Now, let's imagine that we have a program, a big complicated program, that runs a bank. And I am dealing with your checking account. It's very likely that there will be a variable in that program that deals with the balance of your checking account. And the type that is in there is going to be some sort of numeric value that permits decimals. Let's not go any further into it than that. But there is going to be a variable, very likely called balance. It's going to have ones and zeros in the memory location referenced by balance, and it is going to be treated as a numeric value so that we can add things to it and subtract from it. Now, it's very possible that there are several parts of the program that can adjust the balance. One of them is going to be a part of the program where you go into an ATM and say, I want to take some money out. So it is going to subtract. And then there's going to be another one for maybe from the ATM or maybe from a check you mailed to the bank. It is going to permit that value to be incremented. But the bank, being the clever people that they are, know that people would like to withdraw more money than they have. So they want to impose a rule that says you cannot withdraw more money than you have. It wants to make that not possible. So that if someone tries to reduce the value of balance below zero, then you can't. It'll say, no, that's an invalid operation for this piece of data. It will reject it. It will prevent that from happening. Ultimately give a message to the user in some manner. Well, how do we enforce that rule? The typical way of thinking of that would be, well, what we're going to do is every place where you try to manipulate the value of that balance, and it might be from numerous places within the program, from deposits and withdrawals at ATM to deposits and withdrawals at a bank teller, may have a different set of code, to where it adjusts to give you interest or to subtract service charges. So that balance value is going to appear in many places throughout the code. And if I want to protect that, that means in many places throughout the code, I must go in and put in some code to verify that when it is being adjusted, that it is not reducing the value below zero. And we've got to test those sneaky people who say they're making a deposit of a negative amount to try to circumvent that. So we've got to put in some code to enforce what we would call a business rule that says you cannot withdraw more money than you have, and typically this type of code would exist in a number of places. Now somewhere along the way they came up with the idea of procedural programming, where we would write a procedure called deposit or withdraw, and if you used it, it would contain the code for error handling. It could be called from every place. The unfortunate part of that is that there was nothing that forced you to use that code. That code was provided for the programmer's convenience, but it was still possible to circumvent it, intentionally or unintentionally, and do invalid operations on the balance. But that was called procedural programming, where we manipulated these values through procedures that took parameters as arguments and tried to centralize some of this code. And why was it so important to centralize it? Because the rules might change. My bank might decide that they're going to let me withdraw $50 more than I have in my checking account because they think it's highly likely that that's a mistake, or that people are going to do that from time to time, or they know that if they let me do it, they can give me a $29 service charge for it, and so despite their belly aching, they're really hoping I do it. So we have this rule, and if we want to change it to $50, or maybe at some point in $100, we have to go in and find every piece of code that has that and change it. And maybe all that code isn't written in quite the same way, so it might be hard to detect, but it might be a simple word processor operation, but we all know how dangerous those are. And even if we do have that code centralized in a procedure, it's highly likely that somebody who needed that procedure couldn't find it at the time and wrote another one that did it. So that the same business logic still has to be corrected or modified in more than one location. So we have a problem with data of particular types, in that when we try to impose certain additional business rules on it, in addition to the logic rules. See, mathematical rules say, yeah, we can make this number less than 0. And if I try to do something peculiar to it that you can't do with numbers, like add 5 days to your balance, that is a non sequitur. That doesn't make sense. Computer will keep you from doing that, but a business rule, which is something we want to impose on top of the mathematical and logical rule, we have to write the code for that. And we'd like to write it in as few places as possible so that when that rule changes, we can correct it in as few ways as possible. And our concept of data types doesn't really account for that, because we have to write the business rules in our code to impose greater restrictions on the types. So now, what do we have? We understand the concept of data type, such as an integer, that it can have certain rules associated with math and logic associated with it. And in our program, we may also have a business rule associated with it. And for an integer, it might be that your age can't be less than 0. Or it may be that if you're going to be a customer of ours, your age can't be less than 18. If you try to put in a value of less than 18, we're going to reject it. So those are business rules in addition to the logical and mathematical rules.